Hello, everyone. Today we will look at the Wi-Fi encryption, cryptographies in Wi-Fi communication. We looked at the Wi-Fi, the wireless network, the concept last week, and by setting up host AP and your laptop can access to our host AP access points, and meanwhile we can capture the packets and the laptop and the access communicate. So you can share some of the messages to shake hands, and finally they share the key and to generate the encryption and decryption capabilities, and therefore wireless network can be secured. So with that concept, we'll look at a little bit of techniques on encryption. Okay, so some of the exercises can be done. Remember that there is symmetric encryption and asymmetric encryption. Symmetric, therefore, keys can be shared, the same key to encrypt and also to decrypt. On the other hand, asymmetric encryption allows both public and private keys, and then one key is used to encrypt, then the other key can decrypt it, and vice versa, depending upon who has the key when that plays the roles. So which roles that the participants plays, sender's role or receiver's role. Okay. So there's two algorithms well known in RSA. Okay, ALC. So this is another version of RC4. So RC is invented by the company RSA, particularly the person Rivest. Okay, Ronald Rivest. So RC, so Ronald 4, and then there is a version 4. So we'll look at RC4. That's the same key can be shared between receiver and sender, but it can generate the keys continually. Therefore, streaming data can be encrypted and decrypted. Code. So see here, you need to first and then key can be right, and then sender can be constructed as an object of by giving the key used to construct an object. So we have object send and encrypt and decrypt. First, sender encrypt the message. Message says, "Hey, John Yoon." Okay. Then it'll be decrypted by, properly decrypted by receiver. What I'm going to do is I'm going to work with you here. I'm going to copy this. Okay. Together. Okay. And then insert here. So successfully done. So what is the key now? Key is Mercy key. And then a sender is created. So how can sender? Sender can be created by, say, S1 is this ARC4, right? So I can say ARC4 and new using that key. So there's this one, and then we can create same thing. So ARC4 using the same key. So now sender will encrypt. Let's say before we do original message is hello Dr. Yoon, can I to this sensitive, then I want to send that message, encrypt that message, original message. Okay, so encrypt it. So what I want to encrypt, then I'm going to say, I call it cipher. So there's a cipher 1. Okay, so cipher, that is what I am saying, right? It's not readable. So decrypt the cipher 1. Okay, and then I would like to see that is R1, cipher 1. It says, hello, Dr. Yoon, can I send to you this? So that is this. This is original, right? This is original message. I mean, this is a message encrypted, and this is decrypted. Okay, so same key is used, same key shared by the two participants. Therefore, it is called symmetric cryptography, symmetric encryption. Okay. Asymmetric, we need to share between. We do not share. We need to create two different keys, public key and private key. But public key and private keys are paired. It's not independent keys. They are first. Okay. From that private key, we can generate public. So the public key and private key are paired, and they take one or the other. So if the message is encoded by say private key and send it to opponent, then opponent can decrypt it by another pair. Okay, that is what it is, right? In Python, that's fine. I'm going to stop this. Okay, hash code. Hash function is a mapping from data of arbitrary size to data in a fixed size. For example, if we have, if we want to, if we have 3 bins to contain data, so arbitrary data comes, then you need to do, you can make a modular and then put that number on the outcome of that modular. So 17 divided by 3, then what is the remnant? Then that'll be the address to this number can be contained. That is the hash function. Okay, so in addition to this, if we can expand, for example, we have 3 bins to contain a number, but there are some number comes. and where can we assign that number to? Then that is number 1. Any number that you have, you can say divided by 3, and what is the remnant? That'll go to the bin number 2, something like that. Okay. Of course, you have 2 or number 0 divided by 3, then it goes to number 0. Okay. So if we have 3 bins to contain arbitrary number based upon hash function, then there is a label to each bin from 0 to 0, 1, 2. So those are 3 bins. That is exactly the modular. When you divide some number by 3, then if it is divided by 3, then of course there is no remnant, so that 0. Okay. There's a hash function. That hash functions, the beauty of the hash function is that even if you have arbitrarily any number from a smaller and real big number, you can very nicely assign that number to those bins. Beauty of that is that once you have that categories of a number, you know now where it is, but you do not know what number that is, right? It's very hard to go back. It's a one directional. One directional is more doable than going back, which means it's very hard to trace back if we have this. So this is the idea that if you have a cryptography, then it should be very hard to go back to the original thing, right? Okay, so that is hash. That's what we did here, and exclusive OR, and that'll be on another module that you can use.